let's look at how to work a parallel circuit. A parallel circuit is going to consist of a voltage source and several resistors connected in parallel. We'll start with 3. Our voltage source, let's make it 10 volts. This will be resistor R1. We'll make it 10 ohms. This will be resistor R2. We'll make it 20 ohms. This will be resistor R3, and we'll make it 18 ohms. The very first thing I'm going to do when calculating or working a parallel circuit is I'm going to have to remember a couple of things about a parallel circuit. The first one is the voltage drops across each resistor in a parallel circuit remains the same. Notice how R1 here and here is connected electrically to both sides of the battery. Also, both sides of R2 are electrically the same as R1, and they're both connected to both sides of the battery, and both sides of R3 are electrically the same. So the voltage drop across R1, R2, and R3 will all be 10 volts. The current, the total current leaving the battery, will be the sum of the current through this branch plus this branch plus this branch. That's Kirchhoff's current law. The very first thing we're going to do is calculate the total resistance of the circuit. The formula for parallel resistance is 1 divided by RT equals 1 over R1 plus 1 over R2 plus 1 over R3. R1, I believe, was 10 ohms. R2, I believe, was 20 ohms. And R3, I believe, was 18 ohms. Now, using my calculator, my calculator has a key that looks like this, 1 over X. What I'm going to do is I'm going to type in 10, and I'm going to hit my 1 over X key, and I get 0.1. Then I'm going to go plus 20, hit my 1 over X key, and I'll get 0.05. Then I go plus 18, hit my 1 over X key, and I get 0.055. Then I go equals. And I should come up with like 0.2055. Now, 1 over RT equals 0.2055. I want to solve for RT. So I've got to do one more inverse here. So on my calculator, I'll type 1 over X, and my RT comes up to be 4.86 ohms. We calculated the total resistance to be 4.86 ohms. My voltage source was 10 volts. The next thing we find is going to be the total current in my circuit. So Ohm's law for I is voltage divided by resistance. Since I'm looking for the total current, this is going to be the source voltage, which is 10, divided by the total resistance, which is 4.86 ohms. And with my calculator, I'll go 10 divided by 4.86, and I come up with 2.0, 2.0, running out of screen there, 2.6 amps of current. Okay, here's our circuit. We've got 2.06 amps of total current. Voltage drops. What did I tell you about the voltage drops? They stay the same. So the voltage drop across R1, R2, and R3 is equal to the source, which is 10 volts. What we're going to calculate are the branch currents. I'll say current through R1, or I may say current through branch 1. Either way, I mean the same thing. Now remember, R1 is 10 ohms, R2 is 20 ohms, and R3 is 18 ohms. So I'm going to calculate the current through R1 first. Ohm's law for current is voltage divided by R. Since I'm looking for the current through branch 1, that'll be R1, and of course the voltage is the same in parallel circuit, so that'll be the source voltage. Source voltage is 10 volts, and R1 was 10 ohms, so 10 divided by 10 is 1, and current is measured in amps. Current through branch 2 is the source voltage divided by R2, so that'll be 10 volts divided by 20 ohms, and 10 divided by 20 should be 0.5. Then the current through R3 is the source voltage divided by R3, which is 10 volts divided by 18 ohms. So my calculator, I'll type in 10 divided by 18 ohms, and I get 0.556 amps. Let's review. Step number 1 for finding working a parallel circuit. First of all, we find total resistance. Second, we find the total current. Third, the voltage drops across each resistor is the same as the source. Fourth, we find the current through each branch. And then what we do lastly is find the power dissipations for each resistor, and that's simply V times I. So for example, if I'm looking for the power dissipated in resistor R1, then I would take the voltage across R1, which you know is the same, and I would multiply it by the current through R1. And that is how you work a parallel circuit.